I'm going to use rules of exponents, and if you think about this, we're going to say 12 to the 3 over 5, and this is the only time we multiply by exponents, when they're outside the parentheses. So it's 3 over 5 times 5 over 1 times 8, everything inside gets it, so 3 over 5 times 5 over 1, and you can see that the 5's are going to cancel. The 5's cancel, and I get 12 to the third times 8 to the third. And maybe that's where they intended me to stop, but, you know, we can go on. We can say that 12 is the same thing as 2 times 2 times 3, right? We can prime factor that to the third power. That's the same exact thing as what we said. And 8 is 2 times 2 times 2. That's 8 to the third power. And we know that everything inside gets the exponent. So we can say 2 to the third times 2 to the third times 3 to the third. And you can verify this on your calculator that this is indeed true. I like that aspect of it. 2 to the third times 2 to the third times 2 to the third. Now it's all about 2's and 3's. And I'm allowed to put common bases together. And I add the exponents. Oops, that's not a common base. Hold on. These guys are all common bases, though. The 3 is odd man out, so he doesn't have a common base, so he's going to stay 3 to the 3. But look at this. The 2 is going to be 3 plus 3 plus 3 plus... It's just 3 everywhere, right? Well, I guess we could have anticipated that. But anyway, there's 5 of these 2's, and they all have a 3 exponent. So when I add those together, I'm going to get 2 to the 15th. So, do I have room over there? No, I better not. So I'm going to say 2 to the 15th, and I still have my 3 to the 3, and I can't put them together because they're different bases. So we'll stop there. All right. So, you know, the fact that they had common terms, we might say a greatest common factor. We could say 4. We could have stopped at 4. We can take the common parts and put those together. All right, let's see what we have here. We're going to subtract this time. We're going to say 11 to the 2 over 5 minus 4 over 5. And that's going to get us 11 to the negative 2 over 5. Well, we can put that underneath 1, I suppose, and say 11 to the positive 2 over 5. And you know, we could square 11. That's what the 2 on top means. That'd be 121. But then the 5th root of 121, you know, I don't think that's going to work out very nicely. So this ought to be good enough right here.